know what you're thinking. I know what you've been dying to know since yesterday. You've probably not even slept. The question you've been thinking is, did Mr. Kent find his whiteboard pen? And the answer is absolutely not. However, Amazon have delivered not one, but 12 whiteboard pens, because even I won't manage to lose 12 of them, hopefully. So we are ready to get back to it. I have a whiteboard pen. I have a whiteboard. You probably don't care about that, but I do. So I'm now ready to get teaching, as long as the whiteboard pen works, which would be nice. So today we're going to be looking at carrying on converting fractions to percentages. We're moving on a bit from yesterday. We're going to make a bit of a leap. Some of it will seem a bit similar, but some of it will stretch you into word problems, so it should be a little bit more challenging. I'm going to start as we always do. Here are all of my strangely coloured blobs with rectangles in their faces. I'd like you to work out who the imposters are, please, and I'm not going to tell you how many there are today. Pause the video, see if you can work it out. Okay, and you're back, hopefully. So, I'm going to start, because I have a whiteboard now, I can actually show you. I'm going to start at the top left and work my way down. So I'm going to start with grey. So 154 times 4. I'm going to lay that out like so on my whiteboard. I'm going to start with 4 times 4, which is 16. So I put the 6 and I carry the 1. Then I do 4 times 5, which is 20, but I add the 1 on, so that's 21, and I carry the 2. And now I do 6 times 1, add the 2 is, well, 6 times 1 is 6, add the 2 is 8. So 816. Where did I go wrong? What did I do that I shouldn't have done? I'd love to claim that was on purpose, but it really wasn't. What I did was I did 6 times the 1, as if that was the number I was timesing by. As you know, it should have been this one here. I would do 4 times the 1, which is 4, add the 2. So the answer is 616. Starting off well today. 616. So grey is correct, so it's not the imposter. Let's have a look at yellow. So yellow, 2/9 divided by 3. So 2/9 divided by 3. Well, the first problem we have here is that 3 is a whole number. To be able to do this, we need to think of it as a fraction. The way we do that is any whole number as a fraction is itself over 1. So 3 becomes 3 over 1. So now we've got 2/9 divided by 3 over 1. This is where you need to remember KFC. For those of you in my group, yes, I mean maths and not Kentucky Fried Chicken. So KFC, keep, flip, change. That means you keep this fraction. You flip this symbol, make it the opposite. You change this fraction. Keep, flip, change. So this becomes 2/9 times, because we've changed the divide, or we've flipped it into a times, multiply, and we're going to change the fraction by swapping it. So the 1 goes on top and the 3 goes underneath. So we've now got 2/9 times 1/3. When we're timesing fractions, we just do what it says on the tin. We do 2 times 1, which is obviously 2, and then we do 9 times 3, which is 27. So my final answer is 2 over 27, therefore yellow is correct. Okay, let's have a look, carrying on. The third one, I could show you it, but I'm sure you're fine doing column addition. I can tell you it's correct. So we're going to move on now to the next one, purple. 0.06 divided by 10. Well, if it's dividing, the number would get smaller. So that would be 0.006. The number has got smaller because the 6 has moved further down the place value chart. This says 0.6, so purple is my first imposter. Let's carry on, see if there are any more. Next one, 23 times 8. They say it's 184. I can tell you that's correct. This one here, you may not have seen before. It says 27, take away 3 with a little 3 next to it. Now, that little 3 means cubed. And as we've talked about before, that means you times it by itself and then by itself again. So 3 cubed is equal to 3 times 3 times 3. So we do this one first. Well, 3 times 3 is 9. And then we take that 9 and we times that by 3. And 9 times 3 is 27. So now it's saying 27 take away 27, because that's the answer to 3 cubed, is 0, which is correct. So black is not an imposter. This one here, 697 times 100, is correct. Moving on to brown, 512 times 1. We know that any number times by 1 is itself, so that's fine. This one here, 7 times 3 times 10. Well, that's fine. We do 7 times 3 first, which is 21. 21 times 10 is 210, so that's correct as well. And now we've got one more to check to see if the final one is an imposter or whether there's just one imposter today. So red says 1/9 add 1/3 add 1/6. Now we can't add these at the moment because the denominators are different. To be able to add or subtract fractions, the denominators have to be the same. So we need to make each of these the same number. The way we do that is by finding a number that each of these goes into. Well, 3 does go into 6, but we can't put 9 into 6. 3 goes into 9, but 6 doesn't. Now I know that 9, well hold on, 9 times 2 is 18. 6 goes into 18. 3 goes into 18. So we can make all of them with a denominator of 18. How do we get from 6 to 18? We times it by 3. What we do to the bottom, we do to the top. How do we get from 3 to 18? We times it by 6. We do to the same to the top. And finally, how do we get from 9 to 18? We times it by 2. We do the same to the top. Now we can add them together. Remember, we don't add the denominators. They stay the same. Two add 6, add 3 is 11. That says 13. Therefore, red is the imposter as well. So we have 2 imposters today. Okay. Moving on. Alright, so very similar to yesterday, I've got 4 different representations here. I've got fractions, decimals and percentages. Which one doesn't belong? Pause the video, work out which one's the odd one out for me. Okay, now the only way we're going to be able to tell which one is the odd one out is if we make them all the same. Because at the moment, because we've got fractions, decimals and percentages, it's hard to work out whether they're the same or not. So I'm going to make them all into I'll make them all into percentages, seeing as we're looking at percentages today. You may have chosen something different. That's absolutely fine. So let's do the easy one. So we've got 50%. That's fine. 0.5. Well, I know that 0.5 is also 50%. So that's good. So I've got two that are the same. This one here, 100 over 200. Do you remember in a previous lesson where I said we need to make the fraction over 100 or 10 so that we can easily work out the percentage or decimal? Well, let's do that here. So 100 over 200 let's turn that into something over 100. How do I get from 200 to 100? I divide it by 2. I do the same to the top. So I've got 50 over 100, which is the same as 50%. So this one is also 50%, which must mean that this is the odd one out. A quarter is the same as 25%, not 50%. Okay. Really should invest in a whiteboard rubber. Small steps. Right, moving on. So, very similar to yesterday, we're starting by looking at a representation on a grid. There are 100 squares on here. However many are shaded in will tell us the fraction. So, I can see here I've got 10, 20, 1. I've got 21 out of 100. If you've got a fraction over 100, the percentage is the numerator. So the percentage is 21. 21 over 100, the numerator is the percentage. Let's have a look at this one then. I've got 10, 20, 30, 40, I've got 50, 1, 2, 3, 4, 5. I've got 55 out of 100. What percentage would that be? Hopefully you said 55%. All right, pause the video now. Can you work out what this one is, please? Okay, so we've got 10, 20, 30, 40. 1, 2, 3. We've got 43 out of 100, which is the same as 43%. And this one here, we've got 10, which is the same as 10%. This one here, in fact, you have a go. Pause quickly, have a go. We've got 70, 1, 2, 3, 4, 5, 6, 7. 77 out of 100, which is the same as 77%. Activity 1 then, for all groups, and I'm hoping you can see this on the video. Can you have a go, please, at working out what the fractions are over 100, and then what they would be as percentages, please? Pause the video now, have a go. Okay, answers are on screen for you. We have 20%, 35%, 81%, and 79%. Now, activity 2 is a little bit different. It's giving you one or the other. It's either giving you the percentage or it's giving you the fraction. But it's asking for the fraction in its simplest form. So let's take one of them together. Now 40%, I've said to you before, the easiest way to turn it into a fraction is to do it over 100. So if we have 40%, that would be equal to 40 over 100. But we can make this fraction smaller. The way we can do that is by working out what we can divide it by. Something we can divide 40 and 100 by. We can simplify it. Now both of these numbers are even, so I could divide it by 2. Both of these numbers are a multiple of 10 because they end in a 0. so I could divide it by 10. So let's do that first. 40 divided by 10 is 4. 100 divided by 10 is 10. So I can turn it into 4 over 10. They're still the same, but I simplified it. However, I can make this even smaller. 4's an even number. 10's an even number. I can divide them both by 2. 2 over 5. And that's as small as we can go. When you're simplifying a fraction, first thing to look for is, can you divide it by 10? Both of them. Because whatever you do to one, you have to be able to do to the other. If you can't do it by 10, can you divide it by 2? Is it even? And if you can't do it by that, see if you can divide it by 3. And that will help you make it smaller. And you keep on going until you can't make it any smaller. So, using that, can you have a go at turning these fractions into percentages and percentages into fractions? And there are your answers for you. So, we're having a look here now at fractions, and we've got them turning into percentages again. Now, if anything, this is actually slightly easier than the task we just did, because a lot of these already are over 100. So we've got 14 over 100. As a percentage, we know that's going to be 14% because it's already over 100. 47%, look at the relationship here. Numerator became the percentage. Percentage, same as numerator. So 47% is going to be 47 over 100. Now this one here, it starts with 40 over 200. And they're using the golden rule of turning it into something over 100. How do I get from 200 to 100? I divide it by 2. I do the same to the top. So 40 divided by 2 is 20. Once I've got it over 100, it's easy. It becomes 20%. This one here is 31 over 50. Now, I need to turn 50 into 100. How am I going to do that? Well, I'm going to double it. And I do the same to the top, which becomes 62 over 100. So to be clear, you need to make the fraction over 100. However you need to do that. Once you've got it over 100, the percentage is just the numerator, i.e. the number on top. Using that, can you have a go, please, at answering these? Turn the fractions so they're over 100, and then work out the percentage, or take the percentage and work out the fraction. Okay, let's have a look then. Here are your answers. See how you got on. Okay. Moving on then, very quickly, we're looking at activity 4. Now, activity 4 is a word problem. It's no more complex. You just need to read the question and work out what it means. So, A says Ruth and Jamal are comparing how much battery life their phones have. Ruth's phone has 55% battery life remaining. Jamal's phone is half charged. Whose phone has more battery life? Right. Whenever you face a word problem, the first thing you need to do is work out what information in there actually matters. So, we do that, apologies, by underlining the important bits. Ruth and Jamal, do we care about their names? No. Are comparing how much battery life in their phones. Do we care about that? No. Entire first sentence, I don't care. It could be bananas or apples for all I care. It really doesn't matter. Ruth's phone has 55%. Well, that's probably quite important. 55%. Jamal's phone is half charged. 55%, half. Whose phone has more? Those are the bits that matter. We have 55%, we have half. What's half as a percentage? Well, that would be 50%. Who has more? The person that has 55%. So Ruth has more battery life. So the next one, James and Yasmin took part in a spelling competition. James got 3/4 of the spellings correct. Yasmin got 75% correct. James says, I got more spellings correct. Do you agree? Pause the video now, have a go at answering that one. Well, the answer is no, they got the same. 3/4 is the same as 75%. Okay. Activity 5 then is aimed at my group, and I'm not really going to explain it because I want you to have a go at it. Have a look at the diagram. Ahmed says 12% of the diagram is green. It doesn't look very green, but that's meant to be green. Chen says 24% of the diagram is green. Who do you agree with and why? Those of you that have a go at that task, I really want you to show me your answer to that on Seesaw, please. And make sure you tag me in it by saying, Mr. Kent, this is the maths task. I want to see how you get on with that as a bit of a challenge, and Mrs. Walkston and I will mark it to see how you get on. It's quite a tricky one. You need to explain why you've picked the person that you have. And there's a very good chance that, you know, might give you a good hint at the leadership award for that one. Not guaranteed, but actually no, that's unfair. I will mention it in the leadership assembly if you have a go at it and I'm really impressed by your answer. That's what I think I'll do. So, that's all for today. Thank you for bearing with, and hopefully the whiteboard pen will still be here tomorrow. For now, stay safe. See you soon.